Hi guys, in this video I'm going to take a look at a big idea in math ed research and math teaching, and that is the difference between additive comparison and multiplicative comparison, or sometimes you'll hear it called additive reasoning and multiplicative reasoning. So to demonstrate this, I'm just going to show you with a problem. So in this scenario, beads cost $10 per pound, and the total shipping cost is $7, no matter how many beads are bought. So it asks, what is the total cost for 1 pound? So I'm guessing most of you are thinking, okay, it costs $10 for 1 pound of beads, and then the shipping cost for the beads is $7. So that's 10 plus 7 is 17. Now, here's where the split happens. 2 pounds. Pause a second. What's the mental process that you're going through to figure out how many beads it costs for 2 pounds? If you did $17, because that gives me 1 pound in the shipping, plus another $10 for $27, there's nothing wrong with that. It's completely accurate. That is additive reasoning. You're thinking about it in an additive way. And there's, like I said, nothing wrong with that. 3 pounds then, we know that's going to be the cost for 2 pounds plus an extra 10. That's 37. And so on. 4 pounds would be the cost for 3 pounds plus 10 is 47. Now I'm guessing some of you thought, well, there's 2 pounds of beads and it's $10 per pound plus 7 more beads. That's $27. If you did this multiplication here, you're thinking multiplicatively. You're thinking using multiplication. And again, it's not necessarily better or worse. It's just different ways. In fact, all students start additively, and your job, especially in about a 3rd grade level, 4th grade, 2nd, 3rd, 4th, is really to be helping your students move to this multiplicative comparison and giving them problems that are beneficial here, because we need to be able to do both is the key. Here, I'm going to skip to 7 pounds. For the additive person, this might be a little tricky. They may just take 47 pounds that they had from 4 pounds and add 10, 10, and 10 to get to 77. For the multiplicative person, they're just going to think 7 pounds of beads times 10 plus 7, that gives me 77 pounds. And then we see this 131 pounds. A student that's really stuck in this additive process, they're kind of just stuck. They're either going to have to do a ton of work and add 10 so many times to get to 131, or it might motivate them to jump over to the multiplicative side. But the problem is, if they haven't been thinking multiplicative up to this point, it's going to be pretty hard to do so. And for them, we'll talk in a future video kind of how to help them. So here we would have 131 pounds times 10 plus 7 equals, let's see, $1,310, $1,317. And this is really helpful when we move into any weight. So in this case, I would take $10 times the number of pounds, however many that is, plus $7 for the shipping. And you can see this sets them up nicely for algebraic thinking, just thinking about things in an algebraic way, not necessarily solving equations or graphing, but thinking with an unknown involved. Big ideas, I've pretty much kind of talked through this already, but we've got additive versus multiplicative. Additive relies on adding, multiplicative relies on multiplication. This is a relatively difficult transition for kids. It's kind of all their life up to a certain point. It's add, maybe subtract, but it's really thinking in the same way. And then it's like, okay, now we're going to switch to multiplication, and it's tricky. It does tend to be more efficient, though, and that's really important for students. Along with thinking about this, we're going to be working with variables, and variables are really just looking at numbers but they're either unknown or they're varying, they're changing on us. So it's important when we use variables to define them. So we say let x be the number of, and it's also important to recognize that variables are not labels. So if you're working with a problem of water in a tank, it would be correct to say W be the number of liters in the water in the tank. Do you see W is a number here? What you don't want to do is say that W equals water. It's tempting, it's often we know what you mean, but W really isn't water. W is the number of liters of water. And that's really it for this video. So additive versus multiplicative reasoning, we're looking at two different types of thinking, and multiplicative helps students transition into this algebraic thinking and the use of variables. And when we use variables, we want to make sure that we define what they mean and use this idea of a quantity, a number of liters of water.